Hi everybody, welcome to my second part. Second subtopic, the first part. It's measuring an algorithm's efficiency, and there will be such a like 2.2 and 2.3 maybe, or I will just mark it to maybe 2.2. Then all will finish. Anyway, let's just continue with this. So I will just explain you how to measuring an algorithm's efficiency with a linear search system and such a different systems. Okay, so let's start with counting the operations. A good algorithm is correct, but a great algorithm is both correct and efficient. The most efficient algorithm is one that takes the least amount of execution time and memory usage possible while still yielding a correct answer. Just think we have a list, and in the list we have a huge numbers or lot numbers. Let's say we have 50 numbers, but we don't want to check each of the numbers. So we just want to find the correct number in the 25 steps. Because if we do it 50 times, it means it's not algorithm, okay? So in linear search, we have such a chart like this, and we just looking the linear time, how to find a result, like half time, okay? So, and we have also, sorry, such an operation. So in JavaScript, we can say 3 plus 1, which is we have 3 times operation in the loops. And one time is, which is for the beginning part, initializing part. And we're using such a n divided 2, which means number divided 2, n number divided 2. Then we can find half number to detect the correct number in the middle of the list. So one way to measure the efficiency of an algorithm is to count how many operations it needs in order to find the answer across different input size. Let's start by measuring the linear search algorithm, which finds a value in a list. The algorithm looks through each item in a list, checking each one to see if it equals the target value. If it finds the value, it immediately returns the index. If it never finds the value, after checking every list item, it returns -1. It means so it is best case, okay? But we are looking good case in here. So as you see, we have here a function and such a things like we already made it. But let me do it in the coding stuff to find a best way, like how we can represent, okay? All right, so as you see here, we have function, and function name is search list, and we have index, which is we starting with the I, and we will use here repeat until. So as you see, this is while loop, right? So we will use their I to increase it to. So, and we have also here what target number and numbers in the function or procedure to just see the what is going on there or what kind of number we are looking for. Okay. So yeah, let's get started. So first, let's say we have function, and function name is search list, right? It was search list, yes. So then we have numbers, and we have target number. So we want to check target number in this case, and the numbers will be there for the checking. Okay, as you see everything here. So now we can indicate I as a 0, right? So then we can continue with the reminder part for loop. So we can use for loop like sorry, while loop, like checking if index is less than uh, numbers dot length. So we can just say while if, right, if I is less than numbers dot length, that we will add it there to check it. We will just say what we must do here such a operations like if. Where's if? Right here. If numbers, then we can put I index to iterate each time in it to see the like checking the result with the target number. If numbers I is equals the target number, then it will just show us the target number. So we just say target number, then we can just come in it and we can just return something else. So in this case, we return index, right? Return index. So index mean is I, right? So we're just returning I in this case. So as you see here, we have index and we want to return index in this case into the that. So then we can just go out of the if conditions and we can just say I plus equals 1 to increase it each time. And we can come the out of this while loop and we can just say return minus 1. If something doesn't work, if the target number is not there, it will just return out minus 1. Yeah, so let's continue with the numbers now to add there. Yes, guys, now let's put numbers there and work with. So we can just say console.log to get it out, search list, and we can put first our numbers. But how we can do it? First, we can indicate a list. Yeah, we can just put such a numbers like 6, 8, 15, 26, 39, and I don't know, maybe like 40, 65. So in this case, we want to check with 15, okay? Our target number will be 15. So let's say our target number is 15. So as you see here, we have first number lists. So in this case, it's the part of function, like it is our parameter numbers we added there. And we added 15 for the target number, which is it is our numbers list item, which is the zero first and second item, right? So in this case, we're just looking for this and we can try with the 26 too, okay? But as you see, we have three operation in here. So each repetition will be three times. I will explain you the method for that, no worry. So when you just run it, it will say minus one. Oh, not minus one. So maybe we do that in different way. So right here, um, let me go back to there. So index was there. Equals, yes, it is. All right. It's 15, but let's say for the 26 we are looking for. Oh, it's minus 1 is y there. I can't understand that, but let me check it in correct way. So let's continue from here. Okay, so I've just added here equals equals equals. I was just forget to work with the JavaScript. I was understand that this is Python. So it's in Python also like this, but yeah, it was not equals. It was equals 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 or equals equals. I don't know. Yeah, it was like that. So as you see here, it returns in this case return minus one, which is the target number is not there. So if we say 26, in this case, it will be like 3, which is 0 index, first index, second index, and third index, as you see this 26. And if we say 39, for example, it will show us 4. So let's do it and check it. Yeah, as you see, this 4. So we are in the fourth index that we made correctness. So as you see, our target number is fourth index in this case, right? But let's do it against like third index, which is 26. So now I will show you how many operations we must do it. Like we need 3 times repetition. That means, okay, 3 time operation in here, right? So then in here with I. So let me just prove you that. So what we are talking about, we have initializing method in here, and we have 3 time for while loop, 3 time operations for this loop. Because look, we are working with the I, right, for the repetition. So we are just looking here how many times we must make operations to find like target number in algorithmic way or linear search way, right? So it is the method. Let me show you what is our method. So we just saying 3 plus 1, or you can say 1 plus 3. 1 is our initializing. So initializing is what? In this case, our I, that one, right? Let I equals 0. And we have 3 times another operation. So other operations is while operation, if operation, and the increment operations, right? It is 3. And we just saying n divided 2, then it gives us results. So what it means n divided 2, n is the numbers in this case. So as you see here, we have 1, 2, 3, 4, 5, and 6 numbers, right? So we can just represent below the same thing together to make such a math operation. We can just 6 divided 2. As you see here, the 6 divided 2 is 3, and we have already here 3. So we can just say 3 times 3, it's already 9, right? So, and we have also 1 in here, so we can just say 1 plus that one, and we can just come down. So as you see, we can say this is 1 plus 9, and it will give us 10. So to find 26 in our search number, like a numbers, we must make like a 10 time operations. It means, okay, I will show you in graph also how you can find it. So for, let's say we have 39, 39. So we are not looking for target number. We are looking how many times we must make operations to find it, because we are looking algorithmically how to find it in easier way, to not check all of the numbers, just some of them. I mean, like half of them, okay? For that, we're using n divided 2 in this case, because 4 time operation is definite operation that we must do each time. But n divided 2 means we are looking in the numbers, half of them. So let's say we have 10 numbers, we only want to check until 5 numbers. So we don't want to see 6, because it is our method in here with the linear search. I will prove you that. Let's say we are looking for the 39. So yeah, 39 will be what in this case? Oh, let me just tag them from there. Let's say 39. It's 4, right? So let's do same operation for the 39. So as you see, we have 6 numbers again in a list, and we are looking for the 39. So how we can find a result? Just think about it. So what we should try, I mean, in this case. So can you think about it? Let's think. So n divided 2 will be again same. As you see, we have 6 number, right? 6 divided 2. It will be in this case 6 divided 2. But our repeating process will change. It will be 4 times. So what it means 4 times? So it will be 1 plus 4, because now our while loops and if conditionals and increment operations will be 4 times. That you see, we are looking for 39, not 26. For the 26, it will make repetition for 3 times, but for the 39, it would be 4 times. So as you see, it will be 1 plus 4 n divided 2, which means 1 plus 4. 6 divided 2 will be again same. And then we will make it 1 like 4, and it will be again 3 times, and the number will change in here. 4 times 3, it's 12, right? So and our 1 is already here, and the number will be what? 13, right? So do you think it is true, or it is in linear search it works in good way? So as you see, our first number was 10, and then we get 13. So there is 3 numbers between them, right? So that's the way we will increase each time 3 by 3 by 3, like this. It will continue up. So let me prove you again. So let's say we are looking for 65, okay? Let's say 65, and let me delete all this. and I will put there again. It's 5, right? Let's come here and say 1 plus 5 because repetition will be 5 times and 6 there. 6 is our total list numbers, and 6 divided 2 it will be again 3, but in this case it will be 1 plus 5 and 1 plus 5. 5 times 3 will be 15, and the plus 1 will make it 16, and if you check it, the last number will be 16. So can you see the pattern in here? It's 10 and it's 13 and it's 16. It's always increasing 3 times more, right? For the operations. So you can understand we have here such a case as 3 is our half of the numbers of list, right? Like 6 divided 2 is 3. If you put there 10 numbers, it will be 10 divided 2, like 5, and it will increase 5 by 5, right? That's the another case. You can just see it in the graph of the linear search. I will show you, just no worry. So as you see, we found the correct answer. So let's go back to the here. I already explained it to you, most of the things in here, but you can just read it. Checks if index is greater than length number. Since it's 1 is not greater than 6, it executes the code inside the loop. It compares number index. It is what it is that I am talking about, 3 time operations. Okay, so the second iteration is making same job, which is it's checking again 3 time. I mean, like, sorry. So you can just one operation, two operation, and 3 time operation. It means, okay. So 3 time iteration, it means, because we have 6 numbers and we are looking for 3 to find the result in the 3 steps. Okay, as you see here, initialize index to 1, which is we talk about it like I equals 1, right? Let I equals 1. It was the first one. So, okay. And the second one is the checking the length of the numbers. It was the 3 time repetition, as you see. And the if conditionals doing same job for the 3 time again in repetition. And return index is 1 time, as I said you before, like it's like a 1 plus 4, like 1 plus 3, as we indicated that. And we have increment index by 1, it's 2 times. By the way, just don't confuse, it's not 3 because it must be 2 times, then it will just output result. So I hope you understand. It's 1, 3, 1 plus 3 is 4, 4 2 plus 3 is 7, 7 plus 1, 8, and 8 plus 2 is 10. So yes, let's say how many operations are required to find number 3 located to first position in the list. So what do you think about it? How many operations are required to find the number 3 located at the first position in the list? So where is the list? Number 3 is in here. How many times we must make operation? Let's say this is our index, and so we are looking for 3. So there will be how many time repetition? Just think about it. So it will start with the index 1, yes, then repeat until it will work there 1 time, and it will work again 1 time here with the if conditionals, right? And it will just return index. It will be our third process, right? So it's here 3 times and it's here 1 times. And if we increase operation, but as you see, we are looking first index. So in this case, do we need it or not? So what do you think about it? Just focus on this. Like, is it something really we need? So I mean, what, let's come here and let's apply same method for 3. But in this case, we don't have 3, but we can do it for 6, right? So if you say 6, what will happen? Let me tag it and run this. It's 0. So it says it's 0. So it's really 0 or not? What do you think about it? So why it is 0 exactly? So it's 0 index. It's true, right? But we are looking for something else. The first one is the starting point, and we have 1 and 2 time operation, 1, 2, and 3 time operation, right? But it doesn't work like this because n divided 2 in this case will be what? So we have 6 numbers again and we are looking for 3, right? It's 3. And what it will be? in here. So there will be no repetition. It will just start and it will done, right? So what it would be as a result. So guys, so just now focus on one thing. As you see our formula in here, but I would like to show you an important point. So if you check here, the operation time, right? So we can get our pencil. Let's say we are looking for the number 6 in this case for here, right? It is our first index. Let's say initialize index will be 1 time. Check if index is greater than length numbers. So in this case, it will be our first index. So then we can just say it is 1, 2. So the another one also will check 1 time and it will be 2 time, and return index will be our third point. So it was the 1 first. So increment index by 1. So in this case, do we need to make its increment, like increment? Do you think so? Because it's our first index. We don't need it, right? In this case, it would be 4, right? So it would be four, let's say 3, 7, 10, like four, sorry, 3. So in this case, we have 3 time operations to find this, right? So 3 and our 1 is already here. So what I'm talking about, so as you see here, we have third item in a list. It's for 10 times. So if we do same job for the others, it will just increase step by step. So like 10, 13, 16, and 19 like this. And if you come the first operation, it would be 4. So do you think so? It's 4 or 3? Because if you make it 3, it will be 3, 6, and 9. It's not 10. So the first one can be 4, and then it continues with 7. Why 4? I explained it to you. First time we must make an increment to go another step, okay? Like from here. Like it will come here, let I is first operation, it is second, it is third, it is fourth, sorry. Yeah. So it will just give us the output in this case. So then another case will be, so 4 will be in this case the fourth operation. So again, look, 1, this is first operation, this is second operation, this is third operation, right? And this is fourth operation. So as you see, we made fourth operation, but after this, so it will just come back here and it will just look again this operation. But in this case, we already had one operation in here. It will just be 1, 2, and 3 times. So it will be 7 if we add it there. 7 time operation, right? So yeah, it will just continue for 7, 10, 13, and etc. in this case. So let's say it is 4 and it is 7. How, like 37? Where is the 37? Let's check this. 37 is second index. In this case, we can say it is 7. And as you see, we already made it like 4 times, 7 times, this one, uh, and this one 13. This one is 16. This one is 19. Okay. And if we make it mathematically, so we can just come here, we can just use this formula for here. We can just, it is for 3 times, but in linear search, it will always give us the same result. So as operation method. So we can just say 1 because we will make 1 time iteration for the first search item is in this case not 6, it's 3. So if we make it like 6 divided 2 will be 3, and 1 time 3 it will be 3, and 3 plus 1 will be 4. And let's see for another one. Let's say 1 plus 2 in this case, and divided 2 means 6 divided 2 it will be 3, and if you make 2 times 3 it's 6, and 6 plus 1 is 7. Okay, I think it's also okay. You understand that. So you can just apply there this formula. For the six, this is worst scenario. It's not good scenario. It's for worst, best, like bad one. For the sixth item of the list, it would be 10 operations to check each of the item. As you see, like 1 plus 3 n divided 2 will be something like 6 divided 2. It will be 3. And 3 times 3 is 9. And 9 plus 1 is 10, right? So let me get my pencil in here. So you can just say 1 plus 3 and 6 divided 2, it will be 3. So just you can make this operation like this. Let's come for the another one. Let's say we have 1 plus 3. So there will be again 3, sorry, not 3 operation. It will be changed. It will be 30 time operation in this case. Because, um, sorry, not 30 time. It's, let's think like a tree. So in this case, our list size is 60, and we can just 60 divided 2. It will give us 30, and 3 times 30 is 90, and 90 plus 1 is 91. So we can apply the same formula for each of them. Let's say 1 plus 3, 3 times, because there will be multiplication. Just don't confuse, okay? We are talking about repetition. So we can say 600 divided 2, it will give us 300, and 300 times 3, it will be 900. 900 plus 1 is 901. So as you see, we fix it. So let me just prove you with the graph. Let's say we have such a chart like this. I will use another method. Let me take a line like this, and another one from here to there. Um, yeah. Okay, let's say we have here 200, or sorry, 100 or 100. Let me use directly pencil. Let's say 100, 200, and 300, 400, 500. Let's say 600, okay? And let's use for here, um, take my, let me take my pencil. Yeah, let's say 800, 600, 400, 200, like this, okay? Let me take it little down, like this. Okay, so in this case, we are just looking result, right? In the linear search algorithm, because we are working with linear system, linear search algorithm, okay? So let me get my line again, and maybe I can make different color, like a, oh, sorry, not this one. I can just change the color of this, but anyway, I will do that. Uh, so as you see, um, the first operation is that one. It gives us 10, right? Let's say our 10 is here. Let me take my pencil with the red. Yeah. 10 is something like here, right? So let's say here. 10 is there. So the second one, if you check this list size operation, 60. So let's say 60 is something like here, um, like let's say here, okay? By the way, it's not 60, but maybe I can just tag this little right and this one little up. Yeah, let's say this is now 60, and 60 is here. So the last one is 901 time operation. So we can just say 900 time 901. So as you see here, we have 600 here. We can just come directly here like this way, and we can just put it there. And as you see, we have graph in that case like this, and we can just see this is linear algorithm, right? So we can just make it for the 600. Look, our list size was the 600, and our uh, operations, maximum operations was the 901. You can just think 901 is in here, right? Like it's, let's say 901, 901, and it's exactly in here, right? Like you can just think like this. It's here. Maybe I can do with different color, but 600 is here and 901 is here. So if you just tag, let me tag another color. So if you just graph it, like line it, it would be like this. Let me use this line. Um, no, not here. Yes, like this. As you see, this is linear search, okay? Linear search algorithm. So let me get my pencil again. So you can just think like this, like this. It comes like 600. Mm, six, yeah, anyway, 600 and it's 901 in here, like this to there. Anyway, you understand what I'm doing. And the second one in here, 91, comes here. And this is, let's say, 91 below, like this. And this is the first one. So as you see, this linear search algorithm, okay? Everything like this, nothing more. I hope you understand it. Yeah, so I hope it's clear. So we will continue with empirical measurements. It will be second part of the this lesson. Okay, it's part 2.1, and um, there will be another part two, and we will just make all of them clear step by step. We can just say part 2.1.1, something like this, or let me just do it like what you know. Let me come here and let's say part 2.1.1 like this, and let's say for this one part 2.1.2, something like this. We will continue with part 2.1.2, or I can just say um, measuring an algorithm efficiency part 1 and part 2. Yeah, maybe it would be better. So let's continue with empirical analysis, sorry, empirical measurements. Let's put part 1, something like this, or part 2. Yeah, I hope everything was clear and you can just make copy paste all this stuff and see you in another class. Thank you so much.